I occasionally come across things on Facebook that are amusing. How I see word problems, math word problems. If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. That makes absolutely no sense, right? And I'd be willing to guess that probably at least half of you, when you see some of the word problems that we're going to do in this class, are going to say, well, that makes about as much sense as the purple because aliens don't wear hats, okay? Yeah, how do you convert pencils into a color or pancakes? I mean, that doesn't make any sense at all. We're not going to have problems like this that actually don't make sense, but we're going to have some that may not seem to make sense to you. I am here to help you understand them. You really can't pass chemistry without successfully doing some word problems. So, if that scares the heebie-jeebies out of you, then maybe when class is left, you can just go screaming off into the afternoon and never come back. But I'm here to help you do this. It's going to take some work, though. You have to do some thinking, okay? It's not just going to come to you. You have to think about it. It's a problem that needs to be solved. It's like a puzzle. You have to work at it. I can't give you a simple formula that's going to work for everything. We have to learn some strategies of how to solve these problems. Many of the problems are going to end up being unit conversion problems, and I'm going to teach you how to do those. Some of them are going to require some specific equations and some simple algebra. And I'm sorry, but there's no way around it. When we're dealing with units, they act like algebra variables, the x's and the y's, a's and the b's, right? You can multiply them, you can divide them, you can cancel them, just like any variable. The process of using units as a guide to solving problems is called dimensional analysis, because the units are the dimension. And dimensional analysis, we look at the units are going to tell us what to do. We're going to start with some simpler problems, and I know some of you could do them a different way without writing the stuff down. The point of starting with the simple problems is that so it does make sense to you, but really, really, write it down, do it the way I'm showing it to you, because when we get to the harder stuff that is coming, and it's going to come over and over again in different forms, dimensional analysis will make things so much easier. It's probably the most useful thing I learned in high school, out of everything. So important things, always write the unit with its number. Always. Always. Every single time. Is it tedious? Yes. Include units in your calculations. Do not magically cancel out those units. Okay, some students do what I call wishful unit canceling. Well, I wish these units would cancel so I didn't have to deal with them, so I'm just going to cross them off. Well, you're going to get the wrong answer. So most problems are going to have a given unit and a unit that you need to find. And the first thing is you have to figure out where you are and where you're going. I was at the Stanford Mall on Saturday, and that place is confusing. Really cool, but confusing. So you go to the map, and you're like, okay, I want to go to Starbucks. Where is it? You find Starbucks. You also need to know where you are. So you need that you are here, that red circle, you are here. It's like, okay, I'm here and Starbucks is up there. I need to go and do this, right? And then you figure it out, and then you follow the path, and you get there. Solving these problems with dimensional analysis is the same thing. You have to figure out what you're starting with, where you're going, make a plan on how to get there, a path. So what we're starting with, what we're trying to find, and then we're going to have conversion factors. And these are going to be one unit over another unit. And conversion factors come from different things. Some of them you may look up in a table. This is one from your textbook. Gives the relationship between English and metric units for length and mass and volume. It also gives a few within the metric system. Anything that's metric to English, you pretty much just have to look up. There's one that you should memorize because we use it so much, and that's this guy right here. 1 inch equals 2.54 centimeters. It'll be a lot easier if you memorize that. Other conversion factors may just use the metric prefixes. So if I need to know the relationship between microliters and kiloliters, well, actually, let's not do kiloliters. Let's just do liters. We'll deal with the kilo later. Well, I know what micro means. Micro means 10 to the minus 6. So 1 microliter equals, micro is 10 to the minus 6. So instead of writing micro again, I'm going to write 10 to the minus 6 liters and then just put a 1 in front of that. You can make any metric conversions if you know what the prefixes mean. So that's where you get the conversion factors. Let's just do 1. We need to get through this chapter. So constructing a conversion factor. So feet and inches. So there are two, there's the relationship, right? We know that 12 inches is equal to 1 foot. So when I make a conversion factor, I'm going to have 1 on top and 1 on the bottom. So I could put the inches on top, or I could put the feet on top. Which one I'm going to do depends on the particular problem I'm going to do. So here's the conversion factor, but I need numbers. What's on top of the fraction has to be equal to what's on the bottom. 1 inch does not equal a foot. 12 inches equals a foot. So I have to put 12 with inches and 1 with foot. If I put the units in the opposite position, the 12 still has to be with inches. So now the 12 is in the bottom and 1 foot is on top. So these are conversion factors. Because the top is equal to the bottom, they are numerically equal to 1. When you multiply something by 1, it doesn't change the value. We're just changing the units. All right, so if I have a piece of paper that is 12 inches long and I say, well, that's 1 foot long, it's the same length. Something that's 2 feet long, it's 24 inches. Those are 2 different descriptions of the same quantity. So that's all we're doing. This isn't magic. We're just describing it with different units. More advice here. Make sure that you actually got to the unit that you wanted to get to. Ask yourself, does the magnitude of the answer make sense? You know, if you find out that this person is 7.2 meters tall, no, something went wrong. And then remember, with those conversion factors, you can write them right side up, or you can invert them, upside down them, because they're equal to 1. And if you upside down 1, if you invert 1, it's still 1. It's okay. We can flip them upside down. So we're going to use what your book calls a solution map. And it's the units that are going to tell us how to do the map. So going from inches to centimeters is a pretty simple conversion. But if we're starting with inches and we want to go to centimeters, we can do that in one step because we have a relationship that we can find, either in our brains or on a table in a book or something. And we can write the conversion factor, 2.54 centimeters per inch. If we're going from centimeters to inches, we're going to use the same conversion factor, we're just going to flip it upside down. And I'm going to do some examples in a minute. So first thing, figure out where you are. What unit are you given? Figure out where are you going, what unit do I want to get to. Figure out a way to get there. That's the hard part. And what path you get, it's not necessarily that there's only one right way to get from one point to another. I could have gone a couple different ways from where I was near Bloomingdale's over to Starbucks. Just choose the one that makes the most sense to you. You have to know the relationships between the units, though. And so we can see this as given, and then we've got a solution map, and this is what we're trying to find. Oh, so many instructions. Sort, strategize, solve, and check. Yeah. Let's do one. Convert 5.60 centimeters to inches. Always read the problem all the way through. then look at the number. So here, there's only one number given, 56.0 centimeters. And so that's my starting unit, because that's what I have the number for. What's the other unit in this problem?
2.54. Oh, 1 centimeter, 2.54.
Well, but the unit in the problem, you're getting ahead of us.
Inches.
Inches. So they're asking about inches. So I'm trying to get from centimeters to inches. We do know the relationship, so we can do this in one step. Because 1 inch equals 2.54 centimeters. That, by the way, is an exact conversion, and so we don't have to consider sig figs when we use that. So here's my starting point, here's my ending point, this is my path. I can do it in one step. So once you have that, it's a matter of following a pattern. Here's my starting number with its unit. I'm going to write that down, and then I'm going to create my equation. However many arrows are in my path, that's how many fractions I'm going to have. So here I've got one arrow, I'm going to have one fraction. Times. I'm going to go from centimeters to inches. These are the units that end up in the numerator of all of my terms. Centimeters to inches. Centimeters to inches. So inches are going to be here. I need centimeters to go away. I'm trying to convert this into inches. So to get the centimeter to go away, I'm going to divide by centimeter. Because just like x divided by x, they cancel out. Centimeter divided by centimeter cancels out. Units first. Get all the units in first. Then put the numbers in. The units tell you where to put the numbers. So much less thinking. You don't have to say, well, do I multiply this or divide this? I don't remember. The units tell you. So inch. In this relationship, the number with inch is 1. And the number with centimeters is 2.54. Double check. Does the top equal the bottom? Yes, it does. I'm okay. Now, multiply and divide. Take your starting number, multiply by the top, divide by the bottom. Some of these are going to have multiple terms. If you just multiply by the top, divide by the bottom, as you go along, you won't forget anybody. You don't need to write down intermediate values or anything like that. So 56, obviously if I multiply by 1, it's not going to change it. If it makes you feel better to multiply by 1, you go right ahead. I'm going to skip that. 56 times 1 divided by 2.54. And my calculator's giving me a mess.
20.
So how many sig figs should I have? 3. This has 3 sig figs. That's exact because I told you it was. So you don't have to worry about that. This is 3 sig figs. My answer should have 3 sig figs. So I'm going to write down 22.0. Those are the first 3 digits. I'm going to write down 2 extras. And then I'm going to write the unit inch. And then I'm going to round it. The reason I recommend doing this is sometimes you round it off too much and you come back later and you realize you needed another digit and you have to do the whole problem again. If you write down 2 extra digits, then you can just re-round it and you'll be okay. So 22.0 inches. The 0.0 is important because this tells us this is 22 inches to the nearest tenth of an inch. Not just to the nearest inch. Any questions? Yes?
So if you're given the conversion factor or SI unit, then you just look at the given for sig figs?
Yeah, so in general, if you are within the metric system, like going from meters to kilometers or microliters to liters, those are all going to be exact. If you're within the English system, feet to inches to miles, those sorts of things, quarts and gallons, those are exact. Generally, going back and forth between English and metric is not exact. This is the one exception you need to know about. So 1 inch equals 2.54 centimeters exactly. They redefined the inch to be exactly 2.54 centimeters. Yeah?
If you take the 22 inches and like converted to picometers, it would still be exact. Because it would still be, you're using a conversion factor of inches that you're in that you came from an exact, and now you're going into picometers.
Yeah, if we wanted picometers from inches, I'd go from inches back to centimeters and then to picometers. This is exact, and centimeters to picometers would also be exact. So you're going to end up with the same number of significant figures that you started with. So I understand that sig figs are challenging for a lot of students. And so here's a shortcut. If you're wanting the A, you got to understand them. If you're just trying to pass, which there's nothing wrong with just trying to pass, usually the number of significant figures you start with is the number you end with. So what's more important to me than getting it exactly right number of sig figs is that you get in the ballpark. So in book examples and problems, a lot of times it's 3. We'll find it's 3 sig figs. So try to learn the rules, but if that just is not working for you and you don't have time, 3 usually works, 3 sig figs. Let's do another example. Meters to kilometers. So, very few words in these problems. Makes it less confusing. Convert 5,678 meters to kilometers. Well, there's only 2 units. So one must be the given and one must be the find it. The one with the number is the one you start with. And the other one is what you end up with. You know what? I'm going to mix this up a little bit. Because I don't have a good example of this one. We're going to say that this was centimeters instead of meters. Okay? So centimeters, and I'm trying to get to kilometers. So we should know what these prefixes mean, right? Centi means 10 to the minus 2. Kilo means 10 to the third. As you're doing problems, try to remember what they mean and then check to make sure that you got it right before you do the problem. But do I know how many centimeters are in a kilometer? I don't know that off the top of my head. Could you figure it out? You could. Is it worth the effort? No, it's not. So here's what you do. You look at this problem that I've changed now. I've got centimeters, I want kilometers. How many prefixes do I have? They both have prefixes, right? Here's 1 prefix, 2 prefixes. If they both have prefixes, if you have 2 prefixes, do 2 steps. If you have 1 prefix, do 1 step. But 2 prefixes, 2 steps. What's the one in the middle? It's the unit without a prefix. So what we want to do here is we want to go from centimeters to meters and then to kilometers. Yes, you could be elegant and figure out the relationship and go between centimeters and kilometers. It's going to take more time, it's going to require more thinking, and you'll probably get it wrong. I wouldn't trust myself to do it. This is fast once you get the hang of it. So, two prefixes, 2 steps. Once we've got the path, we can just go. 2 arrows means 2 fractions. The path is centimeters to meters to kilometers. I'm going to write those here. Centimeters to meters to kilometers. Just copying down what I did. Now I'm going to take this unit that I want to go away. I'm going to put it in the denominator. Put centimeter down there so the centimeters cancel out. And put meter down here because I want the meters to cancel out. Okay? It's a pattern. After I get all the units in there and get all the units to cancel out like they're supposed to, then I put the numbers in. So here I have centi. I don't want to put what centi means on top of that. I want to put the centi up here. I mean the number. You know what I mean. 10 to the minus 2. So here's the nickname. centi, here's what it means, 10 to the minus 2. And then over here, kilos on top, I want to put what it means on the bottom, on the other side. Sometimes they're on the top, sometimes they're on the bottom. But the units tell you where to put them. 1 kilometer is equal to 1 times 10 to the third meters. 1 times 10 to the minus 2 meters is equal to 1 centimeter. Now, some of you can remember that 1 meter is 100 centimeters. Awesome. You go right ahead and do that. I'm going to follow this pattern and be consistent in lecture, and I'm always going to use the 10 to the whatever. 10 to the whatever goes on one side, the letter goes on the other. Now, to do this on your calculator, you're going to have to use your exponential button, EXP or EE. So do this with me. So I've got 5, 6, 7, 8. Why was 6 afraid of 7? Because 7, 8, 9. That number always makes me say that. You can go back and look at all the old videos, that same joke every single time. Can't help myself. 5, 6, 7, 8 times, and then to enter this in your calculator, go 1 EE, just the button, and with my calculator, I press EE and it only shows me an E. That doesn't mean I need to do it again. As you press that button, say to yourself, times 10 to the, and then I enter -2, and then I'm going to divide by 1 EE 3 and equals, and this is going to give me 0.05678 kilometers. I could put that in scientific notation. These are exact conversions. They're within the metric system. I started with 4 sig figs. I end up with 4. All that's happening is the decimal point is getting moved around. If you understand exponents, you can do this in your head by adding and subtracting the exponents. But again, I'm not going to teach you that because most students are not okay with it. Questions?